Good morning again and a warm welcome from La, which we are hosting you today. Today's topic for our third webinar is radiant cooling for office spaces and how your company would benefit from it. Let me quickly introduce myself to you. My name is Dominik Lehnert and I'm working at Zehnder as a technical project engineer. And I'm working for the company now for 3 years.
Okay, then I will also quickly introduce myself. My name is Helena Hülsey. I'm currently the Business Development Manager for Radiant Heating and Cooling Ceiling Solutions for the international markets at Zehnder. I've been with the company for 7 years now, and basically all the time I was focusing on many different aspects of the heating and cooling ceiling systems product line. Today, I would like to introduce you to the concept of radiant cooling, specifically for the application in modern office buildings. But first of all, we would actually also like to get you a little bit. So I would like to ask you to, if you could possibly tell us where you're from right now, or where you are at right now, in which country, and write that in the chat box. Ah, I see Germany right around the corner. Hello, Estonia. Very nice to see that as well. Serbia, Romania, all over Europe, definitely. Hello to Latvia.
Nice to have such a mixed round today. So participants from everywhere, north, south, west, east, great.
Oh, Argentina. Hello. What time is it where you are? I hope you're having a good coffee right now. So very international audience. Thank you very much. Now that we've done this, this is also, the chat box is where you can, whenever you have a question, just put it in there, and we are trying our best to answer it either in the seminar itself or later on, and we will get back to you. So at this point, I would like to start with the actual presentation. When we're talking about new technologies, I think it oftentimes makes quite a lot of sense to have a look back. So in this case, my question was, is it actually a new idea to keep indoor temperatures comfortable all year round? As you can see in this picture, it definitely is not. So in buildings like this, it is possible to keep the temperature quite constant over the year. And actually, this kind of concept is even used in modern architecture sometimes. And there are also some more examples of this. So these iconic Greek, these iconic Greek villages use the white color to keep the heat out of the building. And of course, we all know these shading technologies have been used for centuries to keep the sun out of the building. A little bit more advanced example is actually was applied in the Alhambra in Spain, which was built from the 13th to the 15th century. And the pool of water that you can see here is actually fed by an underground cavern of colder water. So in addition to cooling down the space due to condensation of the water, it actually also actively cools this quite central square in the Alhambra down. And one a little bit more modern example is this pavilion. It was built for the World Expo in Spain in 1992. And there was, at this expo, there was a competition about energy efficient pavilions. And this building that was constructed by or designed by the architect Nicholas Grimshaw won that competition. They were running cold water through the facade and thereby cooling down the building itself, but also getting rid of some of the sun getting in. At this point, I would actually like to address the question what actually influences the thermal comfort in a space. You can see here quite a list of different components, I would say, for indoor climate. So it can be what you are wearing, what you're doing, also where you're coming from, so what you're used to. But not all of them can be addressed by heating and cooling system, but some of them do. So we will concentrate today on room temperature, on humidity, and on air movement, so airspeed. At this point, we would like to actually to ask you a question. What do you think, when does a person feel most comfortable? So I hope that you can see the poll on the screen right now. I will give you a couple of minutes. So thank you very much. Most of you were actually right. The answer is C. The most comfortable climate is actually seen in this corridor in the HX diagram. We can see that the temperature should be around 20 and 26 degrees and between around 40 and 60% of relative humidity. And of course, this is kind of the corridor that should be the aim for us if we are talking about the different kinds of thermal comfort that we can have in an office building. But keeping these conditions is becoming a bigger and bigger challenge with global temperatures rising. This chart shows the temperature development over the last 140 years and the significant increase since the second half of the last century. But not only rising temperatures do have an effect on the cooling demand that we have. Some positive development and some reasons, especially in India and China, that means that the cooling demand is actually expected to triple until 2050. If all of this cooling demand would be met with the conventional air conditioning systems that are the standard today, the electrical energy demand in 2050 just for air conditioning would be comparable to the combined total electrical consumption of the US, the EU, and Japan combined. But actually, cooling is not just an issue for hot and tropical climates. There was one European study done recently that investigated the cooling demand all over Europe to ensure comfortable indoor climates. So at this point, I would like to ask you, what do you think the cooling demand in a rather cold climate like Finland is? I will try to share another poll. I will give you a couple of seconds to answer. Okay, I think most people have voted on this one. I will close the poll and share the results. Actually, again, you're a very clever audience. 64% of you have actually been right about this one. I will hide the results and go back to the next slide. What you can see here is the overview of the finding of the study that I mentioned. As we can see here, I hope that you can see my mouse, is that basically, for now at least, Ireland is probably quite safe from overheating. But if we are looking at Finland, which is here, and Helsinki, which is quite around here, we have around 40 kilowatt hours per square meter and year as a cooling demand. And as you can see, of course, this is not surprising, the cooling demand increases quite a bit especially when you're going to the southeast. So what is quite clear here that even for moderate climates, cooling is definitely something to be considered. But why is it actually that important? First of all, there are some health habits that are connected to high temperatures. If you're exposed to extreme heat, you can experience exhaustion, cramps, and even heat strokes. And some chronic conditions can actually be made worse. All of this means that it is expected that heat-related illnesses will become more common in the future, even in relatively mild climates. But even before some serious health consequences are expected, heat has negative effects like nausea, dizziness, and headaches, and the lack of concentration. Studies found that overheated offices can reduce work performance by 30%. And this, of course, is one of the most important factors considering cooling in offices in general. So at this point, I hope it is clear that cooling is a necessity to have in work environments, at least in most climates. So we should have a look at what kind of solutions there are. Here we have listed 3 solutions. They are by far not complete, but they are the most common ones right now. So we're talking about ventilative cooling, conventional decentral air conditioning, and central air handling unit that also have the capability to cool down the space. First of all, we would like to talk about ventilative cooling. Ventilative cooling, very shortly, uses a heat recovery system, heat recovery ventilation system, and it uses the colder hours of a day to cool down a building. It's a very efficient solution, especially for residential buildings in moderate climate. If you would like to know more about it, I would actually like to let you know that we have another seminar on the 12th of December that is dedicated to exactly this topic. And of course, we will let you know about that and how you can register in due time. It should, however, be said that ventilative cooling is not sufficient in hot climates in most office buildings. Here, the internal loads are usually too high and the comfort requirements to guarantee a productive environment cannot be met. Coming to the next point, the conventional decentral air conditioning systems. These conventional air conditioning devices have once been seen as quite kind of the luxury and the best answer for reducing overheating in offices. They are, however, incredibly inefficient and the cause of many new problems. They are known to be the cause of colds due to sudden and drastic temperature changes. And in the last months, they have also been in the news quite a bit because of the air recirculation that can lead to the transmission and distribution of viruses. If these are not maintained correctly, even outside of a pandemic, and so they have to maintain correctly and regularly, actually, they can be the source of dust and fungi to be distributed through the office space. But they are also quite loud and can create uncomfortable draughts. So they basically have negative impact on all thermal criteria other than the temperature. So coming to the last of our examples, central air handling unit that also have the possibility to provide cold supply air. If they are well designed, they can make a comfortable indoor climate possible. But there's one big downside to this. The cold air has to be transported from the central unit through the whole building. But there are some physical reasons why this might not be the best idea. And this is actually a point where we digress into a little bit of physical characteristics of air and water. And I will post another question to you. And that is, what do you think? How much more energy can be transported in 1 cubic meter of water compared to 1 cubic meter of air? For everyone who might not be so versed in the metric system, the answer is exactly the same if you use square feet. So here is the question. I will launch it. And once again, we will give you a couple of seconds to answer. Still some votes coming in. So at this point, I will close the poll and share the results. So actually, almost no one thinks that the energy is about the same. And then the answers are quite evenly distributed between 33, 330, and 3,300. So let me go back to the presentation and let's have a look at how we can actually get the answer to the question. So first of all, of course, is the question about the specific heat capacity. So as you can see here, the specific heat capacity of water is about 4 times higher than the one of air. The other characteristic that is important to answer the question is the density. And actually the density of water is around 770 times higher than the one of air. So if you combine those two measurements, it's actually 3,300 times as much. So what we are trying to say here, it's much more efficient to use water to distribute the cold to the. Oh, I should probably hide the poll. So I hope you can see the presentation again. Sorry about that. So what coming back to the actual point, what we wanted to show is it's much more efficient to use water to bring cold energy or cold into the rooms that we're trying to cool down. So what does that actually mean? Are we talking about using radiators for cooling? Because that is usually what we are doing, right? We're bringing water into a room to heat it up. Are we just talking about doing the same for cooling? The answer is kind of yes and no. Yes, we are using some kind of radiator. It just looks quite a bit different. So it can look like this, or like this, like this, like this maybe. Or if you wanted to, it can even look like this. And they work a little bit different. Dominic will tell you in a minute a little bit more about the technical principle, but the basis is to have a large surface area that cools down the room. As you can see in this thermography picture of a ceiling that has some cooling panels inside. And this actually has another positive effect on the energy efficiency. To explain that, we should once again talk about the parameters that have an influence on the well-being of occupants. The temperature that we feel is not just what we measure with a thermometer. A usual thermometer will just show the temperature of the air around it. But the actual perceived temperature that we are feeling when we are in a room, on the other hand, is also influenced by whether the air is moving, the humidity of the air, and most important for us, the surface temperature around us. And that means that the perceived temperature can be seen as the average between the air and the surface temperature. And this is a great advantage for surface heating and cooling solutions. Once again, I will try to explain this a little bit better with a small example. If we would have a surface temperature of, let's say, 28 degrees, for example, because it's very hot and sunny outside, we would have to reduce the air temperature to 18 degrees actually, to have a comfortable 23-degree perceived temperature inside the room. If now, at the contrary, we look at the second motivated occupant of our office space, and we would be able to decrease the surface temperature to 18 degrees, it would actually be okay if the air would have 28 degrees, and the little guy would still be perceiving a very comfortable 23 degrees Celsius. At this point, I would like to give over to Dominic to get more into how it all works. Dominic, you there?
Yes, I'm still there. So let me quickly tell you something about our solution for ceiling panels. And before we start with our products, I would like to show you the principle how our products are working. Good. So what can we offer you? We have different products in our portfolio. I would like to start with the Carboline panel, and our metal ceiling panels are available in different versions. As you see on the right picture, we have a sail as example, and they're also available in closed ceiling versions like a lay-in panel. And we have also the option to put in perforation into the panel for a sound absorption. A quick overview about the Carboline. The panel has a steel plate with a copper pipe and graphite sandwich as an activation, and if needed, we can also fit an insulation on it. As a next one, the second one, like also in metal ceiling, is in the same working function, but not with a graphite activation. It is with an aluminium activation. And on the right side at the picture, you see a closed ceiling solution for such a metal panel. Again, the same metal cassette, and also possible to fit insulation in it if needed. What we also have as an alternative is, compared to a metal ceiling, a gypsum ceiling. So we also have gypsum modules, or plasterboard modules called, in our portfolio, which are mounted in a subconstruction, and these are lying then on the surface of the gypsum board. Here we have a heat transfer and physically the same effect like in a metal ceiling. Also possible to have these as a smooth version or a perforated one. So since a few months we have a new version or module in our portfolio. It's called Zehnder Fleximo. This is different than the other ones because here we have only the activation. And the reason why we updated our portfolio is that sometimes we face the problem that some space needed to activate it afterwards in buildings. So when you have an existing ceiling, metal ceiling in that way, you can easily extend your heating or cooling surface with this module. It's glued inside the metal ceiling. So these are the products we can offer you for your need. When we compare now radiant cooling versus cooling with air, of course, these are different systems. But we face some benefits at a radiant cooling. When it comes to easily reasonable benefits, then we have no maintenance in it. They are noise and draw less. So also what you can use smaller ducts, and the room temperature can be higher even if that you don't feel it uncomfortable. You also do not have some space that is needed on floors, so you can activate or you can use in floors different things like lights or other things. Also, big benefit is when you use a radiant cooling system, you also can use it in the heating period. So you have a two-in-one system in that way. And of course, we have other additional benefits which can be integrated in the ceiling. Next one, please.
Thank you, Dominic. So far, I think it's my turn again.
Yes.
So just a couple more words from my side. So why radiant cooling solutions solve the problem of overheating? As we have discussed before, there are other factors for good air quality as well. A dedicated air handling system is still required. Our argument is actually it can be designed a lot smaller. That way both systems can complement each other. And talking about air quality and air handling units, I would also like to already tell you that our next webinar will be on the 12th of November. It will be in the afternoon at that time. And if you are spontaneous and already want to register for this one, you can right now use the QR code, quickly scan it with your phone if you would like to. But of course, we will also inform you in due time on our social media channels as well as via email if you have received that kind of information before. At this point, I would actually like to make a little bit of a summary of what we have been talking about. We have presented you a very energy efficient cooling solution that uses water instead of air. One thing that we've not gone into right now is, in detail at least, is that one of the positive things of surface cooling and heating actually is that you can use relatively high temperatures in the case of cooling. So we are usually talking about 16 to 19 degrees and relatively low temperatures for heating. So this is very, very well suited for use with a heat pump, for example. At the same time, we can actually increase in the case of cooling the design temperatures, which also means that the complete system can be designed smaller. The active cooling system does not interfere with anything in the room. It does not have it does not cause any draughts. We don't have any air movements that could be uncomfortable, and we have a great design and architectural freedom. And one thing that, again, we've only hinted at, of course, this system, as we've presented it today, is not only suitable for cooling, but also heating at the same time. This is one thing that was not the focus of this webinar. We will probably have future events where we get a little bit more into that. So at this point, I would like to thank all of you for joining us. I would like to thank Dominic for his expertise and his participation.
Thank you, Helena, too.
And of course, right now we have time for any questions that you might have. At the moment, I do not see any questions coming in.
Yeah, we have one question that can we have the presentation?
Yes, thank you. Definitely. If you want to have the PDF of the presentation, just send one of us or both of us an email. And the video of the presentation will also be uploaded to YouTube in the next couple of days on the Zehnder channel. We have one question. How is Fleximo different to others? Well, Fleximo, do you want to answer that, Dominic?
You can go on if you
Okay.
want.
Of course I want. So the Fleximo is actually, it's an activation that can be delivered without the metal cassette. So for example, if we're looking at the alumine carboline kind of closed sealing modules for metal sealings, these are completely activated with a metal cassette. However, it is configured, delivered directly to the building site and then installed there. The Fleximo is actually just the activation. So you can think of it as what is inside the metal cassette. So these modules can be brought to the building site, and they can there be used to do the actual activation. That has the opportunities to you would be able to activate an already existing metal sealing, and it could also mean that you have a little bit more freedom on the building site during installation. For example, you don't know at the first point already how many panels you actually need, either to fulfill the heating and cooling demands, or you have some built-ins in your room that you are not quite sure which kind of panel would fit. So that is kind of what the benefits of the Fleximo are.
Okay. We have still another questions. Let's go through these. One question is it possible to integrate the system in a residential house? In general, yes, it is possible. Sorry, Helena.
No, after you.
I started. So in general, yes, it is possible. But this has to be designed very well. And if you are interested in further information, then please get back to us. So if that solves your question quickly. One other question is, Fleximo is suitable to all metal cassettes or special are required? In general, it fits in every metal cassette. Of course, a metal cassette can have influence on the output. For example, if you use a normal steel metal cassette, you have a worse influence than if you would have an aluminum cassette. And when you install the panel, of course, the installation is important, that you be sure that when it's glued in, that everything is clean and done correctly. The sizes are also variable what we have. So on request, we can give you further information to that.
Then I see another question. Can the floor heating be left out, if I understand correctly, if we're using this system? And there I have to say clearly yes. I mean, this is one solution if you're using it for heating. That basically means that the output is comparable to the underfloor. There are some benefits for both systems. We of course are big fans of ceiling heating. Again, we will probably make it another seminar concentrated on that. We will let you know about that. So I don't. There's one question about software for products and MagicCAD. Actually, about MagicCAD, we do have BIM files for the products. For the MagicCAD, actually, I think so far we don't have MagicCAD, but the BIM files that can be integrated in Revit, for example, those we do have. So if you don't have any more questions, I once again would like to thank you for joining us. Of course, if in the future you will have any question, use the contact shown here to get to us directly. And one thing at the very end, after this meeting ends, you will have the possibility to give feedbacks. We created 3 short questions. It should really not take longer than 2 minutes. And we would very much appreciate it if you would take the time to rate us a little bit and help us improve the webinars in the future.
Thank you from my side too. Thanks for participating. And if you have any questions,